In this video, we're going to be looking at the law of diminishing returns. It is something that you'll see come up in the course. It is a an application of the concept of concavity in an economics context. So the idea, let's say that we're looking at a function that represents how much dollars we're putting into something, like maybe not necessarily an investment, but like into a business or into an operation, into a service. And then we're also going to look at the output in dollars. So here's our input. And then we've got output is the y-axis. Again, that's in dollars. Okay. And let's say that our function looks something like this. Again, one of these kind of super flat looking, whoops, I want that whole thing to start at 0. There we go. Almost a flat looking S. No, I keep messing this up. Let me try this again. There we go. That looks way better. Okay. And it does actually start at 0, 0. If we invest $0 into this thing, we don't get anything out of it. Okay. So this is what we're looking at. Very flattened out S curve. Now, let's think about what happens with the rate of change of the slope. Right here, kind of in the middle of the graph, we can see we have an inflection point. Right? We have an inflection point there because the graph is changing from concave up to concave down. So by definition, that is an inflection point. And let's call that point C, which means that the value on the y-axis would be f of C, and the coordinates of the inflection point are C and f of C. Okay, now why do we care about this inflection point? Well, if we think about what's happening, when we look at the input from x being 0 up to C, we have concave up, right? So the more we put into the input, the rate of change of the slope is increasing, right? If we spend each additional dollar that we spend in the input is making the output increase at a faster rate because it's concave up. But once we hit an input of C dollars at the inflection point, the graph switches to concave down, meaning that each additional dollar spent after C has less of an impact on the output than it did before, because the rate of change of the slope to the right of C is decreasing. So we call this inflection point, that is the point of diminishing returns. Whoops. The returns on our investment have ultimately kind of less value after that point than they did before it. Okay, the point of diminishing returns. So if we invest beyond that value C, it's not considered a good use of our capital. It's not a good use of our investment. We wouldn't want to do that. So identifying that inflection point is an important thing to be able to do in the field of economics. So let's take a look at an example where we're doing this, okay? Or we're using or finding this point of diminishing returns. So we have a revenue function, and it is negative 3.21 x cubed plus 62.14 x squared plus 172.92x plus 48.65. And that's for 0 less than or equal to x less than or equal to 14. And here what the revenue is in millions of dollars generated by cattle farming. And then our X represents the number of farms. In millions. And we want to find what is the point of diminishing returns. Okay. So again, this point of diminishing returns occurs at the inflection point. To find our inflection point, we are going to find r double prime of x. We're going to find the second derivative of r and set it equal to 0 because the inflection point occurs when the concavity changes from negative to positive or positive to negative. So to find that point, we want to find what x value makes our second derivative of this revenue function equal to 0. Whoops. So first, we've got to find the first derivative, right? So again, we're going to take the 3, bring it down front. That's going to become a multiplier. And when we multiply negative 3.21 by 3, we get negative 9.63. And then that's going to be an x squared. We're subtracting 1 from the exponent. We're going to bring the 2 down front here. It's going to become a coefficient that is multiplying that 62.14. And when we multiply that by 2, we get 124.28. And then that's just going to be plain x, right? Because we take 1 away from the exponent. And then 172.92x, that's just going to become 172.92. And then that constant term, the derivative of that is 0. So there's our first derivative. Now we're going to find our second derivative, okay? 2 comes down front. It's going to multiply our negative 9.63. So that is going to be a negative 19.26x. The second term there, 124.28 times x, the x is going to drop off when we take the derivative and leave us with the 124.28. And then the derivative of the constant term becomes 0. So here is what we have for our second derivative. And to find the point of diminishing returns, we need to determine what value of x causes this to be equal to 0. So negative 19.26x plus 124.28. When is that equal to 0? So I'm going to subtract the 124.28 over to the other side. Whoops. And then we're going to divide both sides by negative 19.26 to find our x value. And I am going to do this on the calculator really quickly because that is not going to be a well-behaved number. So 128 divided by So we're looking at about 6.45 if we keep 2 decimal places. Whoops, 6.45. Okay. So that is the x value of the point of diminishing returns. And so now we want to actually find the point of diminishing returns, right? This is the x value. If we go back to the definition of the point of diminishing returns, the y value is where we take that c, so the value we just found, and we plug it into the original function. So we're going to plug that into the revenue function to find out what actually is the revenue at that point. And now, unfortunately, I don't remember what our revenue function was. Let me look it up. It was, okay, there we go. So we've got negative 3.21. We're going to put in our x value of 6.45 qubit plus 62.14 times our x value, 45 squared, plus 179.92 times our x value, 6.45, and then plus 48.65. And that will give us the revenue that's associated with that. So if we plug all of this in, let's see, again, I am doing this on the calculator. So we have negative 3.21 times 6.45 cubed. Then we have plus 62.14 times the 6.45 squared plus 179.92 times the 6.45 plus 48.65. I get R of x, or R of 6.45 rather, is approximately equal to 2,932.95. And so there is our point of diminishing returns. 6.45 for the x and 2,932.95 for the y. So what are we saying here? Well, remember again, this represented the number of farms in millions. And then this represented the revenue. Revenue units were in millions of dollars. Okay, so this is telling us that since this is 6.45 million, that is 6,450,000. If we increase the number of farms past that point, each additional farm added is going to have less impact, okay, to the revenue. And what is the revenue when we have 6,450,000 farms? Well, it's $2,932.95 million. Okay, so that is our point of diminishing returns.